When Nikon announced its historic acquisition of Red Digital Cinema, the imaging industry braced for a slow, multi-year integration process. Traditional corporate consolidations typically yield minor firmware updates, co-branded accessories, or incremental color profile options before any serious hardware harmonization occurs. However, the authenticated supply chain data and prototype telemetry logs surrounding the upcoming Nikon Z8 Mark II reveal that Nikon has bypassed all conservative roadmaps. The Z8 Mark II is not a standard iterative update. It is an aggressive, foundational realignment of the hybrid camera market. By fusing high-end Hollywood digital cinema infrastructure directly onto a blazing fast-stacked CMOS sensor architecture, Nikon has engineered a platform that erases the distinction between an elite commercial photography workhorse and a dedicated cinema camera. This device is positioned to act as a disruptive market force, targeting the core market share competitors like Sony and Canon. In the development of next-generation camera bodies, manufacturers frequently confront a critical fork in the road. Chase superficial megapixel counts for marketing superiority or optimize spatial temporal throughput for professional workflows. While widespread internet speculation hinted at a jump to a 60-megapixel sensor to match contemporary high-resolution bodies, verified hardware blueprints confirm that Nikon has deliberately retained a 45.7-megapixel architecture. This engineering decision reflects an understanding of real-world operational bottlenecks. Pushing full-frame sensor resolutions significantly beyond 45 megapixels introduces severe, diminishing returns for the vast majority of working professionals. Higher pixel density inherently reduces native low-light pixel sensitivity, inflates storage overhead exponentially, and dramatically compounds the processing latency that induces rolling shutter artifacts. More critically, ultra-high resolutions create immense thermal challenges inside a compact, unvented hybrid camera chassis. Instead of expanding the pixel array, Nikon's engineering teams focused entirely on maximizing sensor readout speeds and data pipeline efficiency. The Z8 Mark II utilizes an advanced Fast-Scan Stacked CMOS sensor designed to clear its entire imaging plane fast enough to completely neutralize rolling shutter distortion under rapid panning conditions. This high-speed array feeds into a completely re-engineered processing pipeline. Rather than relying on a single processing unit, the camera introduces a dual-chip EXPEED processing engine. This dual-chip configuration splits the compute workload. One processor manages the foundational image pipeline, high-speed encoding, and hardware input-output arrays. The secondary chip is an application-specific processing blocks dedicated solely to real-time artificial intelligence computations and machine learning inference. This structural upgrade directly resolves the core real-world challenges that limited the original Z8. Heavy computational power draw, thermal throttling during complex tasks, and temporary tracking latency during erratic subject movement. The original Nikon Z8 earned praise for its deep learning-based subject detection and autofocus capabilities. However, conventional mirrorless autofocus systems remain fundamentally reactive. They read the sensor data, identify an edge, face, or eye silhouette, and adjust the lens elements to converge contrast or phase data on that coordinate. While this loop happens at up to 120 cycles per second, it exhibits a distinct latency lag when encountering extreme, chaotic vector changes, such as a bird darting through a dense branch canopy or a close-quarters athlete, making an instantaneous change of direction. The Z8 Mark II transitions the autofocus architecture from a reactive loop to a predictive model via its predictive intent autofocus system. Driven by the dedicated AI subprocessor on the EXPEED engine, this tracking mechanism runs deep learning models trained on millions of frames of sports telemetry, erratic avian flight patterns, and complex human kinetics. Instead of simply calculating where a subject is based on the previous frame, the Z8 Mark II analyzes velocity, angular momentum, and skeletal joint orientation to mathematically infer exactly where the subject will be milliseconds before the movement occurs. This predictive capability is reinforced by firmware-level inference layers that keep tracking active even when visual data is compromised. If an athlete turns their back completely, or if a wildlife subject passes behind a tree trunk, the camera does not drop focus to seek the background or the nearest high-contrast edge. It maintains a virtual lock on the estimated spatial position of the subject, ensuring that the moment the target reemerges, the optical path is already pre-focused on the exact plane of interest. The leaked engineering blueprints, supply chain manifests, and software telemetry paint a clear picture. The Nikon Z8 Mark II is built to break the current tier conventions of the digital imaging market. It acts as a direct challenge to traditional camera lineups, offering specifications that undermine the commercial justification for separate, high-cost cinema bodies and photography setups. By delivering clean internal REDCODE RAW video processing, predictive AI autofocus capabilities that actively calculate target vectors, a robust internal thermal design, and a 32-bit float audio recording architecture, Nikon has consolidated an immense amount of high-end commercial production hardware into a single hybrid body. Priced at a highly aggressive target of $4,299, the Z8 Mark II represents a powerful strategic move from Nikon. One that changes the performance expectations for hybrid field equipment and forces creators to seriously evaluate their current lens system commitments.